Hello, CountSacke here, back with the first video for GD Dynamics. In this episode, we'll be deriving the unit of length that I will be using throughout the rest of this series. Of course, if there's something new or wrong, I will come back to update this. This video is extremely important because in order to properly apply physics or even mathematics in a consistent way, we need a sense of scale. To be more specific, we need an official definition of what length is in Geometry Dash. In the real world, the official SI unit of length is the meter. 1 meter is defined to be exactly the distance that light travels in 1/299,792/458 of a second, or about 3.34 times 10 raised to the negative 9 seconds. All units in real life are defined using constants. So, to be able to properly make an official unit of length for all Geometry Dash players, we would need to find something that is always constant. Luckily, GD comes with a very amazing feature called the level editor. The level editor is at the heart of what makes GD live on today. Many custom levels are constantly being pushed out by creators, so taking a look at it, you can see that there's a beautiful feature called a grid. These lines provide a basis for where things can be placed and provide us with a basis for a unit of length in GD. These grid lines are amazing. However, there's one very big problem with this. If we were to zoom in or out while in the editor, the amount of pixels for a single object would change, meaning that pixel measurements become obsolete, but not hopeless. Instead, we need to consider a ratio. Now, this at first may appear to be something very complicated, but there is already one answer: official game files. Now let me be more specific. The pixels of a game can vary due to multiple factors, but when you're going through the game's files, it allows for us to give official counts for pixels. So if we locate the Geometry Dash files, you'll be able to find this PNG image, GJ_GameSheet-UHD. This file contains a lot of the textures for the game's blocks. Opening the file in GIMP allows for you to see a bunch of textures. There are particularly a bunch of textures that could serve as amazing candidates, but none fit better than the basic square shapes. Why the square? Well, there are no curves, slopes, unequal lengths on edges, or uneven edges on some of the squares. Particularly, the first cube would be the best one to use for the basis, the one you see the most in Stereo Madness. Now, using GIMP, you can open this file and measure the size of the first cube, and it is found to be exactly 122 pixels by 122 pixels. Now that we have a basis constant size for the cube in pixels, we now have to find something in the game to compare it to. Simply enough, the size of a single square in a grid is almost exactly one square. Particularly, there is 1 pixel on all sides that covers part of these grid lines. So we can simply reduce the square grid size to be officially 120 pixels by 120 pixels. This size is honestly much more reasonable since many textures can scale nicely with this. So, with this size, we can now use screenshots and measure the size of the grids to properly scale things to an official unit, which I will declare as a block. If you got problems with the name, fight me. So, the official definition of a block is the length of a line on one side of a single grid square in the level editor, where the line is 120 pixels long, excluding 2 pixels on both sides of a line for a square, which is used to overlap one single pixel of the grid line based on the PNG file called GJ_GameSheet-UHD. The unit of a block is B. If that made no sense to you, okay, I'll simplify it to you by expressing it in mathematical terms. 120 pixels is equal to 1 block, or in proper units, 120p is equal to 1 capital B. So if everybody would like to be able to properly convert the length of something in pixels to edges, here's a formula that you can use. 1b divided by 120p is equal to L divided by M. Isolating L, you get L is equal to M times 1b divided by 120p. In the equation above, M is the amount of pixels long you measure a line to be, and L is how many blocks long the line is. Now, this might actually become problematic once you try to measure diagonal lines, but this can be simply overcome by using Pythagorean theorem. We all know this, come on. Okay, fine, I'll say it anyway. M sub x squared plus m sub y squared is equal to m squared. Just take the square root to both sides and congratulations, you isolated m. Plugging this into the original equation, you get m is equal to 1b divided by 120p multiplied by the square root of m sub x squared plus m sub y squared. And that's it. There's nothing really else to do, so in this episode we've defined and named an official unit of GD, the block, and derived 2 formulas for converting pixels to blocks. Now before I leave, I would like to mention that I will be using decimals a lot throughout the series, and to make things simple, I'll make 1 unit in decimals equal to 1 block. That's really about it, so thanks for watching and— Wait. I'm sorry that this came up very late in the video, but the definition of a block that I said earlier is wrong. Why? Because I decided to subtract 1 off all the sides. My misconception was that the empty space in the grid would be the size of 1 grid square. However, 1 grid square does include those extra lines of pixels on the sides, so a block is actually 122 pixels long. Now, the official definition of a block is the length of a line on one side of a single grid square in the level editor where the line is 122 pixels long based on the PNG file called gj_gamesheet-uhd. The unit of a block is capital B. Now the correct equations are the following. Just replace 120p with 122p. I'm sorry that I wasted a lot of time with the wrong numbers, but I already made about 95% of this video, and this was really the only place where I could put it in, so once again, I'm sorry. Now, I'm done, so thanks for watching and hope you enjoyed.